think it's good. No, that's loud shit. Alright. I believe this is all going through. I hope it is. Sounds like it. Alright. Let's just get started. Today we are going to be doing a programming challenge. It's been a little bit. We're going to be looking at how to create the Connect 4 game in Java. So I'm just now realizing that maybe might not be the best time to do this, because there's going to be a lot of Java stuff in here that I haven't put in the tutorial. So could be a little advanced, but you know, if you're up for a challenge, you're up for a challenge. I should just get the 1 second. Let me just fix this thing quickly. If you're wondering, we are listening to the Mario Kart soundtrack right now. Oh no, it's disconnected from Wi-Fi. Just give me 2 seconds. Alright, so if you don't know what Connect 4 is, I will play it, because I feel like you should know what it is. Otherwise, where's your childhood? Like, honestly. So I'm pretty sure this is alright. Yeah, it's looking good. So it's also called 4 in a line, apparently. Don't ask me though. And all you have to do is you take turns with 2 people, and you put chips into this grid here, and you have to connect 4, as the name implies. So let me just X out of this here. So if I wanted to play here, look, this asshole's trying to get this shit. So let me just get the diagonal moving. Oh my god. Alright, let's do a hat. How about that? Oh my god, he just lost the fucking game. Look at this idiot. I win. It's almost like I could just play this for hours and I'd win every fucking time. And no, I did not put this on easy. It definitely isn't. But anyway, you kind of get the gist here. You play until you insert a thing into the column and it falls down to the lowest spot, and yeah, and you gotta connect 4. So we'll be looking at that, and how to do that. So let me actually get a nice image of Connect 4 here. Alright, this looks good, and I'll annotate it for you people who don't know what this is. Okay, nice. There we go. Okay. So you can connect 4 along the grid, so horizontally, vertically, or diagonally. Here they have it diagonally. But if we were to think about this programmatically, you have to consider really 3 main things. So how to represent a board, and in our case we are going to use a 2D array. I mean, seems pretty obvious. So we'll have like each thing represented. So like if you converted this into a grid, it would look a lot like a 2D array. So a grid with I believe it's 7 columns and 6 rows. So let me just try and draw this out. 2, 3, I don't know how to draw. 4, 5, 6, and 7. Nice. Alright, another rows. 3, 4, and then 5. Alright, so that's my inability to draw in a straight line. It's definitely not because I have Parkinson's or anything. But anyway, we'll usually use the bottom left as 0, 0. And then you go 1, 2, 3, 4, 5. Then 1, 2, 3, 4, 5, 6 for the columns. So it's like that. Each grid point will have some sort of number to represent a color. So in our case, we can use 0 for empty, 1 for red or yellow, and then 2 for the other one. So this board would look like a 1, 2, 1, 1, 2, 2, 2, then a 0, 2, 1, 1, 2, 2, 0, then 0, 0, 1, or 2 rather, 1, 1, 1, yeah, then 0, then a 0, 0, 0, 2, 0, 1, 0, and then zeros in the top 2 rows. So this is how it would look like in memory. So if we were to debug our application at a certain time in the middle of the game, this is what it would look like. Now, in order to, another thing that we'll have to consider is how to drop or how to insert pieces. So let's say we had, if we said insert into column 0, you go here, you start at the top, just 5 of a piece, no. 4 of a piece, no. And you go down to 0, 0 has a piece, so you want to insert it above. So that's dropping. Then, so let me just write that out actually. So the board and then for dropping, you have start at the top and go until you hit a piece. Go down until you hit a piece. Alright. And finally, the most obvious thing and the whole reason why I'm creating this video is how to check for a win. So here you see that the win is here. I'll just highlight it actually. But it's not as simple as just doing that, because if you wanted to brute force it, like in tic-tac-toe, you can probably brute force it because there are like only a couple possible combinations. There's 8 possible combinations, so it wouldn't, I mean, even that's kind of sloppy code to write that 8 if statements or whatever. But here it's a 6x7, so there's going to be a lot more. I'm actually going to see how many there are. So checking. So let's see, we have our horizontals. So on a horizontal row, how many could we possibly have? We could have here to here to here, here to here, so we could have 4 possible ones. And then there's 6 rows, so 6 times 4. Vertically, it'll be 7 times 3, I believe. Because there's 7 columns, and you could have a possible like that, or like that. So only 3 possible combinations in a column. Now positive diagonally, so upward sloping, so positive diagonal. Let's see. Well, there's only 3 possible rows, right? Because you could have this, this, or this, right? So that's 3 possible rows to have an upward sloping diagonal on, and then on each row you have 2, 3, 4. So a 3 by 4 is 12, and it's the same with the negative diagonal. So 3 by 4, and then negative diagonal. And then you get another 3 by 4. So this is equal to 24, 21, 12, and 12. Add those together, we have a 24 plus 24 is 48 plus 21 is... No fucking... Is it really that number? Is it the nice number? There's no fucking way it's that number. I covered all them, didn't I? I think I did. Alright, you know what? Funny. This is not intentional. I actually just figured that out. Yeah. So anyway, you would have, if you wanted to brute force it, you would have to do 69 possible combinations that you have to check through. So 69 if statements or conditions, and you definitely would not want to do that. That is very sloppy code. So we have to figure out some sort of procedural way to check this, and procedurally meaning it's pretty much instructions. Like you go through some path. It's kind of like with the Perlin noise terrain generation. That was procedural generation. And the way you'll do this is you'll have to travel through like the possible paths at each spot. So let's say you started at 0, 0, and you started here. There's three possible paths. You'll have to take that into account as well, because it can't go to the top and left. So it can only go to the right, up, and then up and right. So there's only three possible paths, and you'll just increment it each way, and you'll determine how many consecutive pieces are there, and if it's 4, then you return true or get a win, whatever. So then but there's no real good way to do that with that, or there's a clever way to do that rather. Why did I say there was no good way? There is a very clever way to do that, and you start getting ideas. Oh, if I'm repeating this at each step, maybe there's some sort of recursion involved here. So if you recursively check in the same direction and then return the matches in front of that, then you could test that number in the kind of hub or the origin of the recursion, and maybe that would actually work, and it does actually. So then this creates the problem of how we can store directions. So if we look at, I'll just create a piece right here. So let's say we had this grid piece right here. I'll make this a little bigger actually. From this origin, we could have 8 possible directions. So north, northwest, or northeast, east, southeast, south, southwest, west, and then northwest. So 8 different possible combinations. So we can't just store them as N, N-E, E, or whatever, because that would be kind of useless, first of all, and second of all, it wouldn't be too easy to like convert to and from. So the way you would do this is actually just store it as something like this, so as vectors in a way, because you're going to be incrementing, so you'll store the incremental value for each direction, if that makes sense. So if you start at this, and let's say we were doing northeast, so to get from this piece to from this grid to the next one to the northeast, we would go 1 to the right and 1 up. So northeast is equal to, I'm going to use vector notation, so 1, 1. Southeast is equal to 1, negative 1. Southwest is equal to negative 1, negative 1. North is equal to 0, 1, because it doesn't increment in the x direction, so it only goes up 1 up in the y direction. Brings me back to the days. Okay, thank you, Yash people. Yeah, but it turns out that when we actually look at this in the code, which we will in a second, there is no actual need to do all 8 directions, because if we start at 0, 0 and we first go by column, then by row, we will only need to store 4 of the directions, because the principle behind that is if we have 2 squares, checking up and right is the same as checking down and left. So if we started at, let's say, 1, 1, and then we went to 5, 5, and we're going to run into 1, 1 first, because we're going from 0, 0 up to whatever the top right is. So checking from 1.1 to 5.5 is the same thing as checking from 5.5 to 1.1. So in order to reduce the redundancy, you would have to you only need to store 4 of the directions, and you can choose the 4, but in terms of efficiency, we want to get the ones that are likely to be found first. So we will choose northwest, north, northeast, and east. So we will be choosing these 4 right here. And it's not a coincidence that we're omitting their opposites. So yeah, because these are direct opposites. So going northeast from 1.1 to 5.5 would have the same result as going southwest from 5.5 to 1.1. So that's just, once again, reducing the redundancy. Okay. Now we can actually get into writing this code. So I don't think this should take too long. It was mainly the concepts that I wanted to go through, but you know, this is a good programming exercise. I had this problem a while back when I was in one of my comp sci classes, and I kind of figured out the recursion, but it was kind of hard to implement because I was such a young mind. Alright, so I'm in Eclipse right now. I'm going to go ahead and create a new project. Yeah, new Java project. I'll call it Connect4 and use the JDK and click Finish. Don't create a module info. It's not necessary. Alright, first thing you want to do is you can create packages. You don't have to. I'm not going to, just because if you're not creating like a library or a larger project, the packages are not too necessary. Like, we're only gonna have 2 files here. We could have, you know, we'll just do it in one. We'll consolidate. How about that? So we'll just have a Connect4 class here. You know, in that case, we could actually do this outside of Eclipse, but I'm just going to do it inside of Eclipse for now, and then we'll test it outside of Eclipse as well. So public class Connect4. So since the Java tutorials that I have are not completely up to date, I will be kind of going into depth about what everything means. So the first thing we want to do is we'll have some import statements. Or, you know, no. Let's actually just get hello world out of the way, and then we'll do that. So let's just look at the class first. So it's public, meaning it can be accessed outside of this class. If it was private, you would not be able to access the Connect4 class in some other file. So once again, if you have a larger application or a library, you'll be having many packages, and if you import this package, just like we import, what did we import last time? We imported something last time, but you can import Connect4 as a class. And if classes were private, you wouldn't be able to access it. So that's that. The class just tells the compiler it's a class. We're starting a class, and Connect4 is just the name of the class. Now we're going to do our method. So public, once again, means that you can access it outside of the class. Static, I'm just going to say, I'll save the static explanation for later on, but for now, just no static. I'm just going to talk about it in a minute. Void is the return type, so it doesn't return anything. And then main is the name. So, and then for the parameters, we're going to have string, then square brackets for array args. So once again, if you don't recognize this, this is the classic running method. So this is the starting point for Java applications. This is what the compiler looks for. And we'll just do system.out.println hello world. Alright, so just comparison here. System is a class itself, and it's automatically imported. Out is a public member of it. So system is a public class, like I said, you can access it. Out is a public member, and println is a public member of the out object. So println is a public function, meaning we can access it outside of the stream class here. Alright, now let's get into the imports. So for imports, we will have import java.util.arraylist, import java.util.list, and then import java.util.scanner. So what do these mean? So import is just a keyword to tell the compiler, oh, I want to get the classes from these files or from these packages into this class so I can access them. Array list is just a list, list is a list, and scanner is something that we will be using for input and output in the console. So once again, yeah, import just allows us to take classes from another package, and we'll look into that later. But if I were to have, let's say, another class in a different package, I could say import connect4 or import something else, and we could take it. Okay. So now I'm going to get rid of the color representation out of the way. So like I said, in our 2D array, we're going to have some numerical representation of the color. And we're going to use something called an enum in Java. It's we've done it in C++ before. It's just a simple way to kind of represent a fixed amount of values or a fixed number of possibilities of a single value. So we're going to say enum color. You might be wondering, oh, why don't you have the public? So in order to keep this in one file, we can only have one public object definition here. So the way Java works is I can't have two public classes in the same file. The reason why is because the file name has to be the same as the object name that it is defining. So if we are kind of quote-unquote exporting this connect4 class, we cannot export another enum. So putting public here would give me an error because it must be defined in its own file. However, if we only want to use it here, I can just keep it as no access, and it'll be defined as private, so we won't be able to access it outside of the class. Now to define, let's just do the constructor first. So in an enum, it's kind of like it's pretty much a class, just with its own type. So it works the same though. So we will have members. So private byte value. So notice now, I did not put the static here. So what is the difference between something static and non-static? So essentially, static means that you don't have to initialize an object. So once again, I talked about this before, but classes are essentially templates for objects. You can instantiate instances of these templates and create instances of the objects in turn. And if you have instances, you have access to all of these non-static members. So each instance has its own set of non-static members. The static members are just defined at compile time for the class itself. They don't change from instance to instance. So a non-static member will only be available to an instance. So you'll have to instantiate an instance first before having access to these. Give me 1 second just to check something. What the fuck? Alright. Okay, now for the constructor, we're going to say color int value. So this is just a constructor. Looks a lot like C++. Pass in an integer value, so 0, 1, or 2, and we'll just say this dot value is equal to, now we need to explicitly convert. So in parentheses byte and then value. So the reason why we need to explicitly convert is because this is a narrowing conversion. We are going from an integer, which is 4 bytes of memory, to 1 byte of memory. And the reason why Java, in Java, a byte is 1 byte, whereas a char is 2 bytes. That's just because it uses a different character set than C++. So yeah, why is it giving me this error? Syntax error on token byte. Oh, okay, yeah. So in enums, you need to define the instances of the class first. So we're going to say empty, and we will initialize it with a value of 0. Then red will be initialized with a value of 1, and then yellow will be initialized with the value of 2. So we are essentially calling the constructor for these instances of the enum class. So think of these as think of empty, red, and yellow as instances of the color enum or color class, as it pretty much is a class in Java. And we're just calling the constructor here. And then the last thing I want to do in this enum is create a function. So public char get code. So now notice I have a public member, so this can be accessed outside of the class. And char, meaning it returns a character, and get code is the name, so we will be returning the kind of character code here. So I'm going to say, I'm going to create a switch of this. So I want to determine what type, which one of empty, red, or yellow it is. So I'm going to say case empty, or rather case red, return R in single quotes for a character, case yellow, return Y, and then finally default for anything else, just return in a space. So just like that. So once again, this public thing here means that if we create an instance of the color class, so if we access say color.empty, we are essentially accessing a stat. Think of this is going to be confusing. These are all kind of static instances of the class. So we are generating instances of the class, but they are static, meaning that you can access them without instantiating your own color. And we'll see what it means and how to use it later on. But we can call empty.getCode and get a space, red.getCode and get an R. So just like that. Okay. Now we're going to go into the actual connect for class. So we're going to start off with some constants. So what I'm going to do here is I'm going to kind of create the equivalent of your C++ define. So the reason why I'm comparing this to C++ is because I usually do C++ stuff. So I'm just going to try and create that conversion, but it is easy to go from C++ to Java. There's just a couple things that Java pads for simplicity's sake. Okay, so we're going to say private static final byte number rows is equal to 6. Private static final byte number of columns is equal to 7. Private static final byte number of directions is equal to 4. So once again, just remember we're doing 4 directions because it is redundant to do all 8. There we go. Yeah. So it's redundant to go forward and backward. Check that both times. Alright, so the only keyword you don't know here is final. Simply means you cannot change it after. It's like const. So you can't change these values after. That's usually what, and the typical naming scheme for final static final variables is capital with underscores. Otherwise, you guys could probably figure out what these keywords mean here. So if you want to pause the video and figure out what this means, I'm just going to go through it. So private means that it can only be accessed within the connect for class. Static means that you don't need to instantiate an instance, but you can use it inside of a connect for instance. Final, once again, means that it is final, and then byte is a type, name is equal to some value. Now we're going to have our directions array. So the way I'm going to do the directions is I'm going to represent it as a 2D array, so a list of pairs, kind of. So I'm going to say private static byte directions, and it's going to be a 2D array. And I'm going to say is equal to, then just to instantiate a 2D array, you can just kind of instantiate it like this. So it's curly braces to represent the outside array, and then for each element we're going to have another array. So for the first one I'm going to do northwest, so -1, 1. So that's northwest. Then for north it's 0, 1. And once again I'm going x, y. So that's north. Then 1, 1 for northeast. Then 1, 0 for east. So I'll just comment here, so array of incremental values for each direction. Alright, so those are the private static variables. Now we're going to have some private variables. So these are going to be variables that I want to have their own copy for each instance. So for each kind of game instance, so we're going to have a board, direction, stuff like that. Alright, so we're going to do this here. So we're going to have private color board 2D array. So 2 sets of square brackets. So this is just a 2D array of colors. Essentially, again, we're using the enum, so that's an object. Like that. Then we're going to have a private. Now we're going to use list, and then the template is going to be byte array, possible directions, and then a 2D array of that. So this will be a 2D array of a list of possible directions. So it's like these are going to be the elements of the list here. So the way to kind of think about it is, for each element, we're going to have a list storing the possible directions that it can go. So for, let's say, the position 1, 3, or 3, 1 rather, it can go in all 4 directions. But for something in like 0, 0, it only has 3 directions. Or in 0, 6, it only has 2 directions. Or even in 5, 6, the top right, it has 0 possible directions. Because once again, we're not going to be checking backwards. And then next we're going to have a private scanner. So this will be the scanner that will allow us to read input. Now for the constructor, we're going to say public connect for, and then we're going to pass in a scanner. So this dot scanner is equal to scanner. That's all we're saying. So we're going to pass in a scanner object, which will allow you to read the input, and we just assign that reference to the class. Alright, so now I'm going to do function definitions. So we're going to say public void init. So this will be a function that initializes the private variables, so the board and the possible directions. So public means it can be accessed outside of the class. Void just means it doesn't return anything. A better definition for public, rather, for a public non-static method is, if you have an instance of this class, you can access it outside where you have the instance stored. So like if I create an instance of this class, in another file, I would be able to access connect4.init, but I would not be able to access connect4.scanner, possible directions, or board. Next method is public void print board, and it's just it'll print the board out, all the codes, same keywords, doesn't return anything. Public void play, so this will be the function to actually play the thing. Then we have public boolean insert, and we're going to pass in a color and byte for column. So this is a method that returns boolean, so I'll just return true to remove the IntelliSense error. And so yeah, it just this means that it returns a boolean type, so true or false. And then we have public byte count consecutive. And we're going to pass in a byte R, byte C for column, byte direction array, so the increment values, because we only want to go in the same direction, and then color. The reason why you pass in the direction is because we don't want to go, say, from 2 or 02 to 13, then over to 12. We want to stay in that same direction to check the win. So that's why we have the direction variables. Alright. So those are the function definitions. And now we can just go start at the top. So init. In here we're going to be setting up the board and then also the possible direction. So set up board. So to set it up, we're just going to say board, or to instantiate arrays, rather. I'm just going to say instantiate arrays. So board is equal to new color, and then to set the dimensions of a 2D array in Java, you just you say new color, and then in 2 square brackets, you just specify the number of rows and then the number of columns. So we will be using our private static variables. So number rows for the rows, and then number calls for the number of columns. Then possible directions is equal to new list array, so new row, number of rows, and the number of calls as well, just like that. Now we're going to iterate through each spot, so iterate through each spot. So for byte r is equal to 0, r is less than number of rows, r++. For byte c is equal to 0, c is less than number of columns, c++. Next we're going to say set the space is empty. So board at r at c is equal to, now we're going to access that color instance, so color dot empty, just like that. One second, I'm just gonna text one. Give me half a second. Alright, I'm good. Now we're going to set up the possible directions. So set up possible. And in order to do this, we're going to kind of just go through each space, and then we're going to determine what directions it can go to, and have a connection of 4 pieces. So it's like we're going to start at, let's say, at point 2, we're going to go through the 4 directions and see in which directions there are spaces for 4. For 4 consecutive chips of the same color, because we only want to check in those directions. So we're going to say possible dirs at r at c is equal to new array list, and then template parameter byte array, and then open and close parentheses. So we're going to initialize the array at that spot, and then we're going to say for byte I is equal to 0, I is less than number of directions I plus plus. Now we're going to test in all 4 spots. So for each direction, we're going to go up, down, left, and right, and determine if it goes out of bounds. So if, then in parentheses, c plus 3 times directions at I at 0 is greater than or equal to 0, and c plus 3 times directions at I at 0 is less than or equal to 6, and r plus 3 times directions at I at 1 is greater than or equal to 0, and r plus 3 times directions at I at 1 is less than or equal to 5. So if all 4 of these conditions pass, we will say possible dirs at r at c dot add directions at I. Just like that. So you might be wondering, well, what did I exactly do here? So the top 2 lines in the conditions is determining column, the current column plus 3 spaces to the right. If that's, or 3 spaces, we're determining if 3 spaces in the direction horizontally is within the bounds of the board, so 0 to 6. And then for the row, it's 3 spaces further up or down, and we're determining if that is in the I don't know if that's in the board still. So we could actually just cap this at, like, saying I don't know, which one could we? 2, 3, because technically in the directions, or no, that's actually not true. That's wrong. We can't cap it. Alright, so that's the initialization method. So so determine if space to have 4 consecutive pieces. Okay, now for the print board, I'm gonna be doing a lot of sloppy code here just because I'm too lazy to like write anything. I mean, I think it's fine. So we're gonna have a string to hold a row divider. So row divider is equal to, and then I'm just gonna, I was too lazy to do any graphics, so I'm just gonna do this in the console. So plus minus, so I'm just gonna have it like a plus minus and then the or sign grid. So you've probably seen them. It's like something like plus minus plus minus plus minus plus minus plus minus plus minus plus, then something like that, and it keeps going for however long. And this is just a cool way to print out a table or something. So for the row divider, we're going to say plus minus 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 plus. Is that 7? 1, 2, 3, 4, 5, 6, 7. All right, good. So we need 7 spaces. Now we're just going to create some space in the console. So system.out.println \n for new line, and then a bunch of equal signs, and then \n. And then we want a system.out.println row divider, and then we're going to go into each row. So for byte r is equal to number of rows minus 1, because the way the array is stored is that 0, 0 is the bottom left, so we want to display the top first and then go down. Or you could do upside down connect for. Be kind of cool. So number of rows minus 1, r is greater than or equal to 0, r minus minus. Then we're going to say system.out.print, so we don't want to start a new line, and then it's just a single pipe, so the character next to the backslash. Then we're going to go through each column, so for byte c is equal to 0, c is less than number of columns, c++, ooh, that's a funny one. System.out.print, then we're going to get the character code, so that's why we had that method, so board at r@c.get code, and then we're going to add that to another pipe. I forget what I don't know, is there a name for that? I'm just going to call it pipe, how about that? So because in this concatenation, one of the add-ends is a string, the output will be a string automatically. If this was a character, it would add the integer values of the characters, and that would not be good. And then finally, at the bottom, we want to say system.out.println \n plus row divider. And then at the end, we just want to print out another space in the console, so it just separates it. Just like that. This isn't too important. It's just a good way to visualize it. Let me actually just bring the console up top. Okay. Now for play, we're gonna do some clever stuff here. So I'm just gonna get a sip of water first. Alright, so for play, we're going to have a variable to store the turn count, so byte turn is equal to 0. Then we're going to say while turn is less than number of rows times number of columns. Or, you know what, how about this? Yeah, and then we're going to have a boolean to say boolean is running is equal to true, and then we're going to say while that condition and is running. So the first thing you want to do inside the loop is determine what is the current color. So we're going to say current color is equal to, now we're going to determine that based on if it's odd or even, and I'm going to do a little nifty trick here with bitwise operators. We're going to say in parentheses turn bitwise and 1 close parentheses is equal to 1, then question mark for ternary operator, color dot red, then colon color dot yellow. So what does this mean? So turn and bitwise and 1, any variable bitwise and 1 determines if it's odd or even. Now the reason why is because if we were to do I still my tablet? Oh, I unplugged it. I'm too lazy to plug it back in. Well, anyway, if you bitwise and any number with just a 1, so let's say we had a 1 and then a 1, which is just a bunch of zeros, and then a 1. If we bitwise anded these two, you would get what the last bit is. That's kind of extracting the last bit, so it just returns a 0, because the last bits are 0 and then 1. However, and that means it's even, because there's no odd component. However, if it was 1 there, we would return 1, which makes it equal to 1, so we would get an odd value for the turn. So we just want to get that. And the reason why I say turn is less than number of rows times number of columns, that's just to make sure that it doesn't go over 42, or where there can be no more chips placed. Alright, now for inserting the piece, we're going to say while true, because, you know, it's leaves it to the humans to fuck up inputting 1 to 7. We're going to say system.out.print \n player, and then plus current color plus enter the column, and then 1 to 7. This is just a prompt. You can put whatever. I'm actually not going to say what I want the prompt to be, because it's going to be very confusing to say and then copy down. So just tell them to enter the column, and you can also put the current color there, and it will print out capitals, yellow, capital, red, whatever it is. Then we're going to get the scanner value. So string in is equal to scanner dot next. Honestly, if you don't want to put the scanner as a member or in the constructor, you don't have to. I'm just going to do it just if I wanted to say integrate this game into like a larger kind of thing. If you wanted to have it like in a different spot, that like in a different scanner or something like that. So scanner.next just gets the next character or next line, whatever it is. I actually forgot what it is. Now we're going to parse the value. So we're going to say try. Now it could return or it could throw an exception if there's no, if the string inputted is not a number. So catch exception E. So this is just a try catch block to catch any exceptions. So parse value in the try block, we're going to say call is, oh, I didn't put the placeholder, so we have to create that placeholder. So byte call is equal to 0. And then call in the try block is equal to byte in capital B, so the wrapper for the primitive type, dot parse byte, and we're going to pass in the in for the inputted value. And if this throws an exception, we want to say system.out.println, please input a valid digit 1 to 7, or just tell them not to screw up anymore. And then we're going to say continue to go to the next iteration of the loop. Next we're going to say if insert current color and then the byte value of call -1. So what does this line mean? So we're calling the method insert, and that returns a boolean, so we can evaluate it in an if statement. We're passing in the current color, so the color, and then the column -1. Now we're doing -1 because we want the user to input 1 to 7, because nobody counts from 0, which is kind of weird, but you know what? Comp sci master race, how about that? Everyone should count from 0, but no one will, so. And then once again, we would just want to explicitly convert to a byte, because it's a narrowing conversion from an integer. So if that passed, if it returned true, we're just going to break out of the loop. Else, we're going to system.out.println, please input a valid number, 1 to 7 or whatever. Just tell them to stop being an idiot once again, and then go back to the start of the loop. Do the same shit all over again. Okay. So once they have actually put stuff in after the while loop, we're going to, or after the while true loop, we're going to say print board. So we just want to print it out. Next, we're going to check for the winner. So bool found winner is equal to false. So then we're going to iterate through each spot and figure out where, determine if there's a consecutive of 4. So boolean, actually, still speaking in C. So for byte r is equal to 0, r is less than number of rows, r plus plus. Then for byte c is equal to 0, c is less than number of columns, c++. We're going to say if board at r at c is equal to current color. So this is just another optimization to say, oh, if the new piece was not, or if the piece at this space is not the current color, then don't check, because if, let's say if red played, yellow won't have a chance to win because they would have won on the last turn, if possible. And we also don't want to check for empties, so determine if spot should be checked. Then we're going to say for byte I is equal to 0, I is less than possible ders at r at c dot size. So we're getting the size of the list of the possible directions at that space. I++. So once again, that's where that array comes into play. We're going to say if, so inside the for loop, if count consecutive, and we're going to pass in rc possible ders at r at c dot get I, so we're getting the ith direction in that list, and then the color is current color, and if that is greater than or equal to 4, we will say found winner is equal to true, and then is running is equal to false, and then break. Now outside of the column for loop, we're going to say if found winner, wait, no. Can I put 2 break statements here? No, I can't. So yeah, outside of the column, the column, the column for loop, we're going to say if found winner, break. And then outside of the row for loop, we're just going to print out if someone won. So if found winner, system.out.println, player plus current color plus wins, and then break. And then outside of the if statement, we're going to increment the turn, so turn plus plus, just like that. Now outside of the while turn, outside of the big while loop, we're going to say if is running, the winner was not found. So system.out.println, nobody won. And then I'll put a frowny face. Just like that, just to shame them. I should probably comment this. The reason why I say if count consecutive is greater than 4 is because count consecutive will just count all of the possible, or all of the consecutive spaces. It'll go to 7 if need be. So we're just going to determine, oh, is it more than 4? And if it is, we will simply just say, oh, there was a connection of 4 or more. So determine if connection of 4 pieces. Okay, so increment turn, stop loop. We can also just put this is running is equal to false in this if statement out here, but that's not too necessary. That was just our optimization, or something makes more sense. Okay. Now we're going to be doing the insert method. All right. Yeah, so that's the run method. It's kind of messy, but I mean, it's not that messy. It looks cool. It's very colorful. Am I getting an error? I am. Did I screw something up? What's the error? I don't know. Alright, I'll figure that out later. Okay, so for insert, we first want to say if call is less than 0 or call is greater than number of or greater than or equal to number of columns, return false, out of bounds. Next, we're gonna try and find the spot or find the row that it can be inserted into. So byte r for r is equal to number of rows minus 1, so start at the top. R is greater than or equal to 0, r minus minus. We're going to say if board at r at column does not equal color dot empty, we want to insert it above. So r plus plus, we're incrementing the r once again, and then break, because if we kept r the way it is, we would be inserting it in a space where there already is a thing. So we want to increment r to go above it. Now, outside of that for loop, we're going to say if r is equal to the number of rows, piece is present in the top, so return false. Else, if r is equal to -1, that means that there was no pieces in column, insert at the bottom. So r plus plus, r equals 0 either works. And then finally we want to say board at r at call is equal to color, and then return true. So we're just setting the value. Okay. Yeah, I'll leave that there. I'm just going to fill up my water real quick. What is this? 102.46. This is the oh, it's Cheap Beach. That's a great one. That's a great track. I thought I'd go for a little more cheerful music mix. Just because we're doing a video game, so we're doing a game, so I thought I'd have some fun. And we also haven't listened to the soundtrack before on stream, so why not? Alright, enough fucking around. Let's hop back into it. So final method, count consecutive. We're going to use recursion, so a couple of things that we need to state about recursion. If something is recursive, you have to have some sort of break point, so it cannot just infinitely recurse. It cannot infinitely go to the same method over and over again. That's going to cause a stack overflow, or a heap overflow. I forget which one the functions go to. So as a result, we're going to have some out of bounds check, some checking if it doesn't match, to stop this string of recursion. So first thing is the out of bounds check. So if r is less than 0, or r is greater than or equal to number of rows, or c is less than 0, or c is greater than or equal to number of calls, return 0. So you might be wondering, why do we need to check for these? Don't the possible directions already prevent us from going out of bounds? Well, yes. However, if we started at let's say this 0, 4 here, we go into the right, so we go 2, 2, and it's still finding a match, so it's going to keep going, and it's going to go to column index 7. Now that's not defined, or that's a bad example. Let's say this 1 here was a 2 at 0, 3. It would find the 4, but it doesn't stop. You could tell to stop, but just for generalization, we won't tell to stop, but it's going to keep going after that 2. So it'll go to column 7 if it continues to find a match. So we want to have that out of bounds check. Next, we're going to have another if statement. So if board at R at C is equal to, or does not equal color, color, return 0. So no match. Or I'll say color match check. So else the match has been found, we want to add to the string. So we're going to say return the byte conversion, so explicitly convert. Let me just write the expression and then I'll convert to a byte. So we're going to say return 1 plus count consecutive, and then we're going to pass in R plus dir at 1, C plus dir at 0, then direction, and then color. So what does this statement mean? You're gonna get a IntelliSense error. Don't worry about it. So first parameter is the row. We are simply taking the y value of the row of the direction increment and just going to the next space in the direction. Same thing for the column, except we're taking the x component, which is the 0th component. Then we pass in the same direction and the same color. Now we need to convert a bunch of things to bytes. So convert the increments to bytes explicitly, so that whole expression needs to be converted to a byte. Like so. And then finally, the 1 plus the function call needs to be converted to a byte as well. Alright, so that's the recursive aspect of it. And once again, these are our 2 checks to make sure that we don't recurse forever. And then this will return if it has a maximum, or if there's a consecutive. Okay, so that is all the code actually, or actually all of the logic code. So now we actually get to implement this. So in the main function, we're actually right there. So in public static void main, we're gonna do a couple things. So after the print, we're gonna open the scanner. So scanner is equal to new scanner system dot in. So all we're doing is just saying system dot in. We are passing in this input stream into the scanner. So the scanner will now be listening to the input stream in the console. Next, we want to we're going to instantiate the game itself. So we're going to create an object. So connect 4. So we're calling the class name C4 is equal to new connect 4 scanner. So we're passing in the scanner as a variable into the constructor, and then we're going to say c4.init and then c4.play, and then finally close the scanner. So scanner.close, just like that. Okay, so a couple notes here. We are calling the c4.init and c4.play. Notice how we are calling the public non-static members. If we wanted to say connect 4.init, we would get an error because this is a static member. We cannot make a static reference to the non-static method from the connect for class. Alright, so now let's actually try and run this. And we'll run it in Eclipse, and then I will compile it outside as well, just to check if that works. Alright, so hello world, player yellow, you see how it prints out just the actual reference name of the thing. So enter the column, so I'll say 1, and it prints out the board with a yellow piece in the first column. Now, so I'll check in all directions, so 2, 1, 2, so just like that. So you see it has the 1, 2, 3, 4, up and down, so it says player yellow wins. Now let's run it again. We'll go upwards and we'll go negative diagonal, so northwest. Yeah. So player yellow starts in 4, 3, 4. Why did I do that? 2, 3, 2, 2, and then 1, 1, 1, 1. Alright, so player yellow wins. It has the negative diagonal. So this one right here. Now let's try horizontal. So Y, or 1, 1, 2, 2, 3, 3, 4, and it wins. Now we'll do the positive diagonal. So 1, oops, 2, 1, damn it, 3, 2, 3, 3, and then 4, 4, 4, 4, just like that. So player yellow wins. The upwards diagonal is nice. Now let's try and make sure that the insert method works. So I'll try and input an A. Please input a valid digit. I'll input 0. Please input a valid number. I'll enter 8. Input a valid number. Now let's just try overflowing the column. So 1, 1, just like that. And then if I try inputting 1 again, please input a valid number. Okay, so yeah, that works. Now let's try doing this in the console. So maybe I should just get this open up in a console. Where is this actually? Where's this? Oh, I know where it is. Alright, so let me just zoom in here and go back to desktop. So if I'm currently in the directory with it, so I'm going to compile it. So java c connect for.java. Connect for use unchecked. What? Unchecked or unsafe operations. What does it not like? This type safety. Value. Oh, you know what? I know what I did. So in the enum, you don't need to have this constructor because the value is not relevant at all. So you can honestly just delete that. It's not necessary. So the constructor and the private member of the enum class is not necessary. Now for the unsafe operation, I believe it's referring to this, so I'll just have to add the template parameter. But it doesn't like that. Cannot generate a generic array of list. Doesn't like either of those. Needs unchecked conversion. Let me try adding this. at suppress warnings unchecked. Now let me try recompiling it. Oh, it worked. Okay. So if you don't know what I just did the Eclipse thing, and I just suppressed the warnings of unchecked whatever. So that was the unsafe operation it was referring to. So all it is above the method definition, so above public void init, just say at suppress warnings unchecked. Alright, now if I wanted to run it, so if I press type endure again, we get the class. Oh yeah, so it generates a class for the color enum and then also the connect for. So now we're just going to say Java connect for, and what? Cannot find or load main. Am I doing this? I don't know if I'm doing this right, to be honest. If you don't want to listen to me whine about this, you can hop off. But Java compile in CMD. Save the program. Command prompt. Yep. Yeah, I got it. Java C. What? Do I have to compile it to... Alright, let me try this. Class names test... Oh, Java C. Invalid flag, what? Yeah, okay, this is wrong. That image is wrong at least. No, I'm gonna be lazy. Hold on. Clear. Error could not find or load main class. Yeah, I have the Java. Does it not like that it's not in a package? It worked the last time I did it. Alright, I don't know. Might not like that it's not in a package. Let me try doing this here. I'm gonna try typing in package src at the top. That's not gonna like it there. Now let me go into previous directory, say Java C src / connect for.java dir. Now let me say Java source.connect for. Okay, alright. Oh, no, that's also just wrong. Alright, I have no clue how to do this in the command line, so I'm not going to worry about it. Alright, so that's been fun. So yeah, Connect 4. I hope you guys enjoyed. It's been a little fun exercise to do. Thought-provoking. Go think about philosophy after this if you want, but I'm not going to. I'm going to go take a tinkle after I end this, but yeah, so I hope you guys enjoyed, and I will I'll continue. Oh shit, don't look at that. Do not look at that. That's my control panel. Anyway, I'll probably keep adding to the Java tutorial, I don't know. But anyway, you guys enjoyed, and I will see you guys in the next video or stream, whichever comes first. Alright, adios.